Hi, we're going to talk about the next wave of AI in manufacturing, which is powering front office innovation. I'm Scott Sawyer from Paperless Parts. We make quoting and estimating software for custom part manufacturers, and we help those manufacturers in a few main ways. First, we've got workflow management for shops where quoting is a team sport to help you make sure that the right quotes are being worked on at the right time by the right people. We have highly customized costing automation, which includes things like analyzing models and prints. We give you a great digital experience for your customers, and we have open APIs that let you connect paperless parts with the other software systems you use to run your business. Bit about myself. I'm an engineer by training, went to school for electrical engineering. About 8 years ago, I started Paperless Parts. 8 years before that, I actually was working at the largest defense contractor and getting a master's degree at night. And on a whim, I took a class called Artificial Neural Networks. Walked into the classroom on the first day. The professor was about 80 years old, starts talking about neurons, and we're looking at biology slides, and I'm thinking I'm in the wrong classroom. Turns out, super interesting class, learned a lot. At the time, I filed it away as trivia, and now fast forward to 2022, and pretty much all we talk about these days are neural networks. And for the last 2 years, roughly since then, I've been very focused on bringing AI into paperless parts. So here's our agenda. In short, today, the digital thread is broken in the supply chain as custom part data flows from company to company, and this is a great application for AI. And it's important to note that AI in manufacturing is not just LLMs, um, i- i- but it certainly includes LLMs. There are many other models that can be useful, and all those AI models can help reconstruct the digital thread by assisting human experts in dealing with messy, real-world technical part data and documents. So you all know this. AI is all you're hearing about everywhere. You can even quantify it. Here's a chart of Google searches for AI. You can see since 2022, it's just completely hockey sticked. Everybody's very interested in it. And AI is a term that's been around for many decades, and yet the interest in the last few years makes anything before then look near zero. So clearly you're hearing about this. That's not a surprise to anybody. And if your feed looks anything like mine, it's just an echo chamber of AI stories, probably mostly written by AI at this point. It includes good news, bad news, stupid news. Now, it's my job to follow this stuff, and I can't read it all. So if you're actually out there running a manufacturing business, there's just no way. So let's take a step back and acknowledge four important truths about AI. Okay. First of all, it's overhyped on the one hand. Now, this happens to a lot of exciting new technologies because people don't want to miss out. At the same time, it's the most important innovation in decades. So this is a lot more like computers and the internet and not like blockchain, for example. Third, the term can mean anything, which means it can mean nothing, right? There's no authoritative definition of AI, so people use it in a lot of different ways. And there's a technical definition. When a software engineer says AI, they're probably referring to large neural networks trained on massive data sets, things like large language models. But there are a lot of other technologies that get called AI, and it's usually totally valid. But as a result, the term doesn't really mean anything. So when someone says AI for manufacturing, they really might just mean manufacturing with computers, right? So what you need to do is kind of ignore the buzzword and home in on what solutions you can use and how they will help your business. And finally, keep in mind AI is a technology, not a solution. So on its own, it's not going to solve any of your business problems, but you can definitely use it to help you build or to power your solutions. So what does this mean? You're being sold AI constantly. You can't totally ignore it, and not everything marketed as AI is equally intelligent. So what I'd like to do is break down some of the different technologies that get called AI, right? And we'll look at how they actually work. We'll have a couple slides that get a little technical. We'll keep it somewhat light, and then we'll come back and look at ways AI is being applied in manufacturing today. So first of all, very common to see algorithms referred to as AI. And algorithms is just a technical term for code, right? Writing lots of code. And increasingly, software engineers are using AI to do that even faster. But these are still algorithms created by smart people working hard. And you'll see these all over. You'll see these in paperless parts. So, for example, our CAD feature detection and design for manufacturability warnings are all powered by algorithms that we've been honing for years. Another flavor of AI is called expert systems. So this is a term that was popular in the 1980s, and now we're hearing about it all over again. And really, all it means is bringing um, expert knowledge, right, domain knowledge into software. So an example of where we might use this in paperless parts is we have this found in files feature, right, and it searches for thousands of different specifications and materials in your tech data and shows you when those things are found. So is it AI? You could call it that. Is it an LLM? It is not. And then this is where things start getting interesting. So machine learning. What is ML? Well, in machine learning, an equation or model is learned from training data. And it's similar to a trend line, right? If you draw a trend line in Excel through a chart of numbers, right? And what that lets you do is that model, and a trend line is a model, it lets you predict something about a new data point you've never seen before. So if you know its location on one axis, you can use the trend line to predict where it would land on the other axis. With ML, you're relying on data scientists, humans, to use their domain knowledge to create techniques for learning more about data you've never seen before. An example of where you might see this in paperless parts is we actually use machine learning to extract metadata from prints. And the reason we do that is because every print from different OEMs is very different. Part numbers look different. They're located in different locations. And ML helps find those items in prints and in templates you've never seen before. So how does that actually work? What does that mean, machine learning? Well, okay, let's try to do machine learning in about a minute. And I'm just going to give you a flavor of how it works and just get very slightly technical. So this was the first slide I warned you about. All right. So suppose you're trying to do the problem I just described, which is find a part number on a blueprint, and you've never seen a print in that template. Well, what you can do is you can use historical data to train a model to help you do that. And this is the sort of way you might do it. And obviously what we do in reality is more complicated than this, but this will give you an understanding of the basics of machine learning. So what we're going to do is we're going to take every word off of every print we have in our training data set, and imagine we know which one's actually the part number. And for every word, we're going to generate some numbers, right? Some quantities that we can use to represent that word. And for this example, we're going to extract 3 numbers from each word on the page. And the first number, the X, is going to be the number of numerical characters in that word. So the number of digits. In our example here, we've got 77801,210. So that's 8 numbers. So the first number is 8.0. The second number is going to be the number of non-numerical characters in that word. In this case, 3. So the P and the dash. And then the third number, the Z, is going to be the distance from that word to the bottom right of the page. Let's say in millimeters, in this case, 28.5. Can you believe that the number of numbers in the word, the number of non-numbers in the word, and the distance from the bottom right of the page gives you some indication about whether that word is actually a part number? I think intuitively that makes sense. So what we can do is we can go calculate these numbers for every word on every page of our training data, and we can plot those. So I picked 3 numbers because you can sort of graph those in 3D and visualize it. And what we can do is we can take all the words that are not part numbers and let's make those red. And then we can take all the words that actually were the true part number and we'll make those green. In an ideal world, what you're going to get is the red and the greens are kind of separated in space. And what machine learning does is it finds a way to separate those. In this case, it's represented by this blue plane. And now when you get a new print you've never seen before, you can calculate those 3 numbers for every word on the page, and you can figure out if any of the words on the page are in the green area. And then that's your part number prediction. So again, in reality, it's a bit more complicated than that, but that is machine learning in the simplest terms. All right, hopefully you're still with me. So now let's talk about AI in the sense of artificial neural networks. So that was machine learning, right? That's now considered old school. My engineers don't even want to call that AI anymore. So in artificial neural networks, and these have been around a long time. These have been around since the 1950s. But just for the last couple of years, we've had a step change in their capability driven by the scale of these networks and the architectures we've come up with And really, networks learn, and they learn in a very similar way to the human brain. So, an example of where we might use this in paperless parts is when you forward an RFQ email to paperless, we'll read the email thread and try to extract part numbers, descriptions, quantities, and so on. So, that's a large language model trying to understand the plain language in your email thread. But how does that work, right? So, that sounds too good to be true. And the answer is that neural, and this is my second of two technical slides, and then we'll take it up a level. How do neural networks work? Well, they basically simulate a human brain. All right. So this thing on the left, that is a cartoon of a neuron. You have got 86 billion of these in your brain. Up at the top, those are inputs. Those are basically wires, nerves that come into this neuron we're looking at. Right. Then we've got this cell body. So what happens is those inputs send electrical signals into the cell body and charge builds up. And when it builds up to the point that it crosses some threshold, the neuron fires that signal to its outputs, right? And those are shown on the bottom of this cartoon, but those are called axons, right? And those electrical signals go to other neurons in this big network. So your brain is just made up of billions of these. And what we can do is we can simulate these neurons. And that looks like this diagram on the right here, where we see the circles represent a neuron and the black arrows represent connections between layers of neurons. And each black arrow, right, is that connection. And think of it as having a volume knob on it, right? So it can be set to 0, meaning no signal goes through. It can be all the way up, or it can be anywhere in between. So when the neuron fires its output, right, it's going to all those other neurons that are connected to it. And there's different signal levels going to each one. Okay, now that's remarkably, you can train this thing to do amazing things without having to write code explicitly to do it. So the way it works is on the left, those are the input neurons. So whatever you're putting into your neural network. An early application for neural networks that worked really well was OCR, optical character recognition. So in that problem, what we're doing is we're taking, say, a small picture of a letter, and we're trying to figure out which letter in the alphabet that picture is showing, even if we've never seen an identical letter to it before. So the input might be each pixel of that image, whether it's black or white, say. And obviously there's only 4 inputs here, but in real life it may be hundreds or thousands, right, to capture all the pixels in that picture of a letter, right? And then we put that in, the neurons all fire off through their connections, and at the output on the right side, we're going to have output neurons. And maybe in the case of OCR, we're going to have 26 output neurons, right? One output for each letter in the alphabet. And in the ideal world, if we show a picture of an A, we get a nice strong signal coming out of the A neuron and zeros or low signals coming out from the other 25 neurons. Okay, well, how do you achieve a network that does that? Well, you train it on data. So the way you do that is, and you do this thousands or maybe millions of times, you put an input image in, right? And it's going to produce an output that initially is going to be not correct. It's just going to output junk. And what you do is you adjust all the weights, all the volume knobs on these black arrows to make it just a little bit closer to the desired output every time. And then you do another image and you do the same thing. And you just keep adjusting this network, right? When it's getting the right answer, you reinforce the connections. When it's getting the wrong answer, you adjust the connections. And over time, right, after millions of iterations of this, the network starts to converge on getting the right answer, which is pretty remarkable. And that is actually very close to how humans learn. So, and then remarkably, when you build these up into massive scale and train them on a ton of data, you get these behaviors that we see in the modern large language models. So it's pretty remarkable. Okay, so that's it. Done with technical slides. Let's talk about AI and CAD in manufacturing. And I've been collecting some examples, and I just want to highlight. So we just looked at different types of AI. Let's talk about how different things might work when you see these things marketed to you or you see them on your social media. So first of all, automated CAM is a good example. You're seeing a lot of people working on automated toolpaths. How does that work? Well, that's largely driven by algorithms, perhaps with some machine learning or neural networks to help make those more efficient. Is it AI? Sure. Is it is really great up and coming technology that's probably going to change the way you program parts. Another thing I've seen recently, this is a tool called Zoo. You can go in and you can type in plain language a description of a 3D object you want, like a brake rotor. And what it'll do is it will generate that object. Pretty remarkable. How does it work? Well, you have to imagine there's a large language model there, and it's taking your input and it's trying to figure out what steps it should take in a CAD program to build that model, and then it gives you the 3D model. So is it AI? Absolutely. Is it useful? Probably not too useful yet, but it's getting there. And then you may also see, maybe you've seen this video on social media where you take a print and you put it on a desk, take a picture with your phone, and then 2 seconds later, you've got a perfect 3D model of that object. So if the first thing's powered by algorithms, Zoo's powered by LLMs, what is this powered by? Well, at the moment in 2025, it's largely powered by hopes and dreams, because I got to tell you, the technology isn't quite there yet. Will it get there? Perhaps. But if you've looked at real industrial prints, you probably realize that that is extremely hard for a human to do. And at this point, it's not feasible for computers to do reliably for real complicated prints. So, and the reason I highlight this is it's important, as you're getting AI marketed to you, to understand, what's possible, what's realistic, and how these things actually work under the hood. With that in mind, what are the biggest opportunities for AI in your business? Right? It's hard to take in all this information and come away with real opportunities. And I talk to a lot of manufacturers, and here are just some of the examples that shops are telling me they're excited about or actively using, right? Ranked from very mature to less mature. So things like CAD and CAM assistance, you're now seeing a lot of products on the market that can do that. And kind of the next generation, the next frontier would be learning robotics. Certainly robotics have been in manufacturing for a long time, but the next generation of those robotics are going to do a much better job of learning on their own. So it's kind of just as easy to train a robotic arm as it is to train a person. That's what the next generation is sort of offering. So how can you actually use AI today? And it's important to think about different AI approaches on a spectrum, from general purpose to industry specific all the way to custom solutions. And this is just a few logos. There are so many companies doing great work in this area. So on the left, we've got general purpose tools. That's things like OpenAI, the maker of ChatGPT, Gemini, Microsoft Copilot. So these are chatbots and tools that basically, if you use a computer for work, you can almost certainly speed yourself up and make your life easier by using a chatbot to help you with some of those tasks. So if you're not already using one of these things, I would strongly recommend to you that you try them out, because they can really speed you up in a lot of ways. They can draft emails, they can come up with Excel formulas, they can help you brainstorm new ideas. They're really quite useful. In the middle, we've got industry-specific tools, and I'd put paperless parts in this category. So these are companies making solutions for manufacturers, and they've integrated AI into those solutions. So this is a good way to leverage AI to solve a specific manufacturing problem. And then on the right, there are a lot of platforms on which you can build custom solutions. So when you hear about some of the big players like Amazon and Microsoft in this space, being an AI provider, generally, that's something where you, your company or a consultant are going to create a custom solution, right? These companies aren't necessarily offering an off-the-shelf manufacturing solution, but they are giving you a platform on which you can build one. So with all this in mind, as you dive into AI, there are things to worry about. And I don't mean philosophically, I mean quite practically, right? So questions you should be asking your software vendors: where is AI used in your application? What third-party services and partners do you use to provide AI capabilities, right? Most smaller companies aren't generating their own foundation models. They're actually using ones provided by companies like OpenAI, Microsoft, Google, Anthropic. So it's important that you know which of those tools may be used with your data. How is your data used to train AI models? How can I tell when data has been generated by AI in the application? And table stakes, AI or not, if you're evaluating a software vendor, you should really be insisting on seeing results of a third-party audit for cybersecurity. And some of those compliance regimes are things like FedRAMP, SOC 2, and ISO. You should be expecting at least one of those from your software providers. And finally, are your service and AI features compliant with CMMC requirements? That's for folks in the defense industry. If you are pursuing CMMC for your company, you need to understand whether your cloud service provider can be used with those tools. And that means they need to be FedRAMP moderate, equivalent, or authorized. So AI can help your front office surface objective information faster in a clean, intuitive way so you can make more informed decisions. That's our approach to AI in paperless parts. We call it wingman, right? A co-pilot is trying to fly the plane, but a wingman's got your back. And now I'd like to dive into some areas where we've seen AI already have a big impact for manufacturers. One of the first things paperless parts did with AI was quote setup, right? So when you receive an RFQ from your customers, it's often a very complicated process to understand what parts are being requested, review all the attachments to figure out which files go with which parts, and get all of that set up in a software system. With quote setup and Wingman, you can now just forward an RFQ into paperless parts, and it will automatically set all that up. And you can start from simply an email. You can forward it to paperless. Uh, Wingman will read the email text, read the thread, extract part numbers, revisions, descriptions, and so on, and then begin setting that up in paperless parts to save you a whole lot of time. So we can see here, one of the first things that happens is we'll identify a table of quote items that have been requested. You can create those line items in paperless automatically. Then you can go into the attachments, maybe unzip them if necessary, and paperless parts will make suggestions to you about how those files map to the line items in your quote. And a process that traditionally has taken maybe hours now just takes seconds, which is pretty remarkable and will speed you up. The next area where we found AI to be hugely helpful is in dealing with large bills of materials. So here you see Wingman for assembly BOM setup. And, we've recently launched what we call the BOM Builder, where you can upload technical data in the form of 2D and 3D files. We'll automatically extract BOMs from your CAD models, as well as tables from PDF files and Excel spreadsheets. And we will start stitching together that BOM, even if it's located across multiple pages and files. We'll help you easily, we give this user interface that helps you easily edit the BOM so that it isn't necessarily how the engineers designed it, but how you want to manufacture it. And we'll map those files to it so that you can very easily get all those things organized and then set that BOM up in paperless parts. So this was one of the first times we heard from customers about a feature that took a process that used to take maybe even days to set up a hundreds or 1,000 line BOM to now just hours. A huge time saver if you work with complicated bills of materials. And AI driven, because we're able to read that stuff right out of unstructured 2D and 3D data. And what we've been working on more recently is going deeper into drawings, engineering drawings, blueprints, prints, whatever you want to call them. If you work with these, you know that there's a huge amount of variety from between designers and OEMs. And, normal document software does not handle these files well, right? Adobe Reader, for example, doesn't understand GD&T symbols, doesn't understand, how call-out text flows in a print. And you're probably familiar with some ballooning or bubbling tools in the QA space. And some of those tools have auto ballooning features, but they usually require a lot of hand-holding, and they struggle to be successful with a high percentage of real-world industrial prints because, shockingly, engineers don't always follow the standards. So we recently introduced a workflow to help estimators extract that stuff from files and then even create rules based on that. And here is a look at what's coming soon in paperless parts. You can see as soon as you upload part data with prints, you're going to start to see this GD&T and other call-out information get extracted. So this can help you just simply triage and understand what you're being asked to quote. Then when you start to dive into more details, maybe you see something interesting or concerning that you need to account for in the quoting process. Paperless parts and Wingman make it very easy to find that information on the print, right? So you can be very confident that what the AI is telling you is accurate. You can come in and verify it very quickly. And you've probably seen prints much messier than this, maybe with hundreds of callouts on a page. We have this whiteout feature that helps you make sure that the AI hasn't missed anything by simply hiding everything that was detected, which means whatever's left on the print, those are the things you have to go manually verify. And where do we go from here? Well, the next step is what we're calling requirements review, and we're really excited about this. So this helps you turn your complex requirements into guardrails and a simple workflow for your team. So we're able to not just extract the information from prints, but give you a workflow to help take action on those things. So examples would be, if you see a tight tolerance, assign a senior estimator. If you see a finish at an outside operation, or if there's a total run out at a metrology operation. If you see more than 8 datums, maybe you just want to no quote the part, and so on. So this helps standardize all that tribal knowledge that your team has and how to read these prints and take action on them. So our goal is not to automate quoting through AI. Manufacturers don't want a black box that hallucinates a manufacturing plan and price. Instead, our goal is to use AI to surface objective information in a clean, intuitive way so that the experts can make informed decisions about how to cost, price, and make a part. In short, we say AI makes suggestions, humans make decisions. If that sounds interesting, please check us out at paperlessparts.com. And thanks so much for watching.